Okay, so in this problem, we have 10 identical delicious laddus. Okay, hoping you all like laddus. So these are distributed to 3 boys. Okay, now if each boy should get at least one laddu, okay, so each boy should get at least one laddu. We need to find the number of ways in which this can be done. Okay, so the way to distribute these laddus is we can use a trick here. Okay, so what is the trick? So if I line up all these laddus, so let's say these are the laddus. Okay, so laddus are represented by these zeros. I mean, you can call them zeros, but let's say these are the laddus. Okay. So how many? There are 10. So 3 more laddus. Now, what we can do is, because there are 3 boys, we can take 2 cardboards. So let's say these are 2 cardboards. Now, why do I need cardboards? I'm using these cardboards to divide the given laddus into 3 groups. Okay, so if I have to divide the given laddus into 3 groups, I can place these 2 cardboards. Where shall I place? I cannot place them
Starting in
to the left of the first laddu or to the right of the last laddu. I'll have to place in the gaps in between, right? So if you take a look at the number of gaps, how many gaps do I have?
9.
Yeah, so there are 10 laddus. So there are in between them, there are 9 gaps. Okay, so these are the 9 gaps. So if I place, okay, so placing these 2 cardboards in 2 of the 9 gaps. Okay, so in 2 of the 9 gaps. I will be able to distribute them to 3 boys, right? So I'm forming 3 groups. Okay, we'll be forming 3 groups of laddus, right? Do we understand this?
Yes, sir.
3 groups of laddus. Okay, now, I mean, I could have placed, let's say as an example, suppose, I'll try to show you 2 examples here. So if I again put all these laddus, let's say 4, 5, 6, 7, 8, 9, 10. Okay, as an example, if I place my first cardboard here, okay, I cannot place another cardboard here. Okay, so try to understand this. No, I will be selecting 2 places out of 9 places. In each place, I have to place 1 cardboard. Okay. So if I place it here, then what is happening? The first 3 laddus are given to the first boy, right? And now the next, in the gap between the 2 cardboards, we have 5 laddus. So these will go to the second boy, and the last 2 laddus will go to the third boy. Okay, so in case if I place it little differently, let's say. Okay, so suppose if I place the cardboard maybe like this, then what is happening? The first boy is getting 4 laddus, the second boy is getting 3 laddus, the last boy is also getting 3 laddus. So what has happened to our problem? This is called a technique named bijection. Okay, it's like it's a very powerful technique. So what we are trying to do here is we have a problem where we have to count the number of ways in which you can distribute these laddus, but we are converting into another problem which is simple. Okay, so the problem here is there are 9 gaps. If I can select 2 gaps and place the cardboards, 1 in each gap, I am able to do this kind of distribution. So I am selecting a different easy problem where I know the number of ways of selecting 2 gaps out of 9 gaps is as good as the number of ways in which you can distribute these laddus. Do you understand how these are linked?
Yes, sir.
Is everyone okay? Are you able to follow that these two definitely will give the same number of ways, right?
Yeah.
Now
Yeah.
we have studied selections. Okay, so we know if you have to select, let's say, 2 out of 9, all we have to do is just compute 9C2, right? So there are 9 gaps. We need 2 gaps. In each gap, we are placing 1 cardboard. Okay, is everyone okay here?
Yes, sir.
So then we know how to compute this as well. It is 9 factorial by 2 factorial into 9 minus 2, 7 factorial. So the trick to calculate it easily is like, look at 9 and 2. You go down twice. Okay, so 9 and then you write down 2 numbers basically in the numerator. And then you have 7 factorial. That 7 factorial gets cancelled by 7 factorial. So I can just write only 2 factorial, 2 into 1. So this gives 36. So what is the answer? There are 36 ways in which you can do this. Okay, is everyone okay here?
Yes, sir.